This is Precalculus review of Algebra prior to Calculus Part 3, Factoring. I'm taking these problems from Canadian math teacher Jeremy Clausen. I invite you to watch his videos. He's very good. I have my own little slant on what he does, however, and so that's what we're about today. Factoring. When you have a quadratic trinomial such as this one, what you're going to try to do is factor this into a pair of linear binomials. And so you can factor these quadratic trinomials sort of by trial and error. And for numbers such as these, it's not going to be too hard. What two factors are going to compose 2x squared? Well, that's going to be pretty easy. You're going to have 2x and x. And we know we have all plus signs, so therefore we have to have plus here. And then what are your factors of 3? Well, you're really limited. It's going to be 1 and 3. So we can just try them out, see what happens. We can put 3 and 1 here. Well, if we do that, we're going to get 3x, and then 2x times 1 is 2x. So this is going to be added together 5x, which doesn't match our 7x. So these aren't going to work. So I'm going to back up and just change the order. I'm going to put 1 and 3 here. And here we can see we have 1 times x is x, and 2x times 3 is 6x, and they add up to 7x. So therefore, this is going to be our correct answer. Now, there are other ways to do this. I'm going to explain in class later on the x method, where you put your value of b here and ac up here. This is not a particularly difficult one, but I'm going to go ahead and skirt to the next thing anyway. We have negative 6x squared plus 7x minus 2. Well, one thing I have here is I don't like to have this negative sign out front, so I'm going to rewrite this expression by putting a negative sign out front. So negative times what equals 6x squared? Well, it's going to be 6x squared. And then the negative times negative 7x is going to be 7x. And finally, we're going to have plus 2. So we factored out this negative sign. And for this one, I am going to use the x method. We can use trial and error. We have AC here and B. So in this expression here, A is equal to 6, B is equal to negative 7, and C is equal to 2. So we put AC here on top of the x, which is going to be 6 times 2, or 12. And down here for B, we have negative 7. So what two numbers do you multiply together to equal 12, but add together to equal negative 7? Well, it's going to be negative 3 and negative 4. And then we divide each of these numbers by a, and a is 6. And simplify. So negative 3/6 is negative 1/2. And negative 4/6 is negative 2/3. So what we have here is we're going to have the negative sign out front. So we have negative x minus 2/3 times quantity x minus 1/2. And we use what we call the bottoms up method for this. And what we do is we take this, our answer is going to be a negative sign out front, we take 3 times x, or 3x, minus 2, and then we have 2 times x, which is 2x minus 1. And if we multiply all these together, we'll see that we're going to work out as a correct factoring. Okay, next, C. We have x to the 4th power minus 13x squared plus 36. Now, it may not be apparent to you, but this is in the form of a quadratic expression. And what we're going to do is substitute in, and it may not be apparent to you right now what that is, but if we we're going to say let a equal x squared, okay, and then we will do the rewriting, and the substitution is one thing we'll do quite a bit in calculus later this year, especially when we integrate. So what we're going to have, if we let a equals x squared, then x to the 4th power, I'm just going to write this, x to the 4th power is therefore going to be equal a squared, to a squared. So we have a squared here minus, well, a equals x squared, so we're going to have minus 13a, and we're going to have plus 36. And so now we can attempt to factor this quadratic now trinomial, which is derived from our quartic trinomial. So we have the factors of a squared are a and a, and then what two numbers do we add together to get negative 13 but multiply together to equal 36? Well, we know we're going to have a negative and a negative. We'll have what are your numbers you can use? Well, you can use 6 and 6, which isn't going to work. What about 12 and 3? Right, 12 and 3. That's not going to work out. 18 and 2. 9 and, how about 9 and 4? Let's try this. 9 and 4. I think this is going to work out. So now we'll have negative 9a, and we will have down here negative 4a, which together add up to be negative 13a. So substituting back our a in for x squared, we're going to have x squared minus 9 times quantity x squared minus 4. And so that's our substitution back in for a right here and also over here. And this will be our answer. Okay, next. Here we have a cubic polynomial, and it's not readily apparent. These things are harder to factor. So when you see something like this, what I recommend doing is using a technique, maybe the remainder theorem, and first of all the rational roots theorem. So you're going to have the factors of 30 over the factors of 1. So our possible rational roots are going to be plus or minus 1, plus or minus 2, all the factors of 30, plus or minus 3, also plus or minus 5, plus or minus 6, plus or minus 10, and plus or minus 15, and finally plus or minus 30. And what you can have, if you treat this like a function, and we'll say k, if k equals a rational zero, we will try these out. Then we're going to get a using our remainder theorem. So let me just write this out, remainder theorem. And we did this briefly in Algebra 2 last year and in Precalculus. And for that, we're going to try we'll try 1 and negative 1. So f of 1, and what this is, if we get 0, that means 1 is a real zero of the expression. So f of 1 is going to be 1 to the third power minus 10 times 1 squared plus 19 times 1 plus 30. So we're going to get 1 minus 10, or negative 9. Negative 9 plus 19 is 10, plus 30 equals 40. So we say, so therefore, dot, 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 1 is not a zero. And therefore, the expression x minus 1 is not a factor. So now we're going to try f of negative 1, which is going to be negative 1 cubed minus 10 times negative 1 squared plus 19 times negative 1 plus 30. And so we're going to have negative 1 minus 10. So that's going to be negative 11 plus 19 times negative 1. So negative 11 minus 19 is negative 30 plus 30 equals 0. So therefore, negative 1 is a 0. And therefore, x plus 1 is a factor. Now let's go ahead and figure out what we're going to have. We're going to use synthetic division. So we're going to put our value of our 0 out here, which is negative 1, and our coefficients, 1x cubed minus 10x squared plus 19x plus 30. And this is a way of checking our work too, because we're going to end up with 0 if this is correct, if our factoring so far was correct. Okay, so we 1 down here, negative 1 times 1 is negative 1. We get negative 11. Negative 1 times negative 11 is going to be 11. Add these together, 30. Negative 1 times 30 is negative 30. So we get 0. And so what we have is x squared minus 11x plus 30. So we had, for our factoring, we know that x plus 1 is a factor. And so we just have to factor this, what remains here, x squared minus 11x plus 30. So we're going to have x and x. And then we have, we're going to have negative signs here. So what two numbers do we multiply together to equal 30 but add together equal negative 11? That's going to be 5 and 6. And so this is going to be our factoring. Okay, next. Here we have a cubic expression, and so we always look for our common factors here. Well, we have an x in both cases, so x times what equals x cubed? Well, that's going to be x squared. X times what equals negative 9x, which is negative 9. And then we can use the difference of squares. And difference of squares, what is the square root of x squared? X. We have plus minus. And what is the square root of 9? 3. Okay, so this is going to be our answer to problem E. Now, problem F, we have this x to the 8th power minus 1. Doesn't look easily factorable. But when you think about it, we can use the difference of squares, just like we did in the prior problem. And what is the square root of x to the 8th power? Well, it's going to be x to the 4th power. And then we have plus and minus 1. Okay, are we done now? No, because we can further factor this x to the 4th power minus 1. So we can rewrite this as quantity x to the 4th power plus 1, because we cannot factor this binomial. And so we can take this x to the 4th power minus 1, and what's the square root of x to the 4th power? It's going to be x squared. So we're going to have plus and minus 1. And can we factor this further? Yes, we can, because we can take this x squared minus 1. So we have x to the 4th power plus 1 times quantity x squared plus 1. And then we take this x squared minus 1. That's going to be simply x plus 1, x minus 1. So here we have fully factored this expression. Next, G. Okay, we have x squared minus 3. Now that doesn't look like it's very factorable, but strangely enough, this is the kind of factoring you run into in calculus, where you might have to find what we call a critical number. And so even though let's go ahead and see how we can factor this thing. Doesn't look like it's factorable. Well, strictly it's not the way we did before, but we still have a difference. So the square root of x squared is x. Then we're going to have plus minus. And what's the square root of 3? We're going to have square root of 3. Now where this is helpful is if we end up with expression here like this, x squared minus 3 equals 0, we'll be able to solve for x by using this difference of squares in this instance. So strictly not factorable in a conventional sense, yet very useful to us in solving this particular problem. Okay, next we're going to look at common factoring, because what happens is we often will have opportunities for this, and we're going to look at also we're going to look for rational exponents, to radical and also the other direction. And I don't think we did much of this we did this a little bit in Precalculus last year, but not very much. What you're looking for is a common factor, and you look for the lowest power. So we're going to use our common factor between these two is going to be x to the 1/2 power. So x to the 1/2 power times x to what power equals 5/2. Well, 1/2 plus 4/2 equals 5/2, or we could rather say 1/2 plus 2 equals 5/2. So x to the 1/2 power times x squared equals x to the 5/2 power, and then x to the 1/2 power times what equals x to the 1/2 power. What's going to be minus 1. And then we can further factor this binomial using difference of squares. So we have x plus 1 times quantity x minus 1. And then this x to the 1/2 power is what we call a rational root, but we can change this into a radical root. So you'll very often see this x to the 1/2 power written as the square root of x. So we can finally write this, if we want to, as square root of x times quantity x plus 1 times quantity x minus 1. So there we have it. But you could leave it as x to the 1/2 power. That would be okay also. You just need to be used to have enough flexibility between the different forms. Well, here we have 4x to the negative 1 power minus 10x to the negative 2 power plus 6x to the negative 3 power. What is our common factor here? Well, I hope you can see that 2 is a common factor to all these. And we're going to take the least power of x, so we're going to put this as 2x to the negative 3 power. So that's going to be our greatest common factor. So what times 2x to the negative 3rd power equals 4x to the negative 1 power? Well, that's going to be 2 times what equals 4? Well, that's going to be 2. And then x to the negative 3rd power times what equals x to the negative 1 power? What's going to be x squared? And then we have minus 2 times what equals 10? 5. And then x to the negative 3rd power times what equals x to the negative 2 power? Well, that's going to be x to the 1st power. And finally, we're going to have plus 3. And so we can write this as 2x to the negative 3 power. And then we're going to have, see if we can further factor this. I think this is similar to the problem we did earlier. So we had 2x and x, and then we're going to have, let's see, 3x minus 3 minus 2. Yeah, it's going to be negative 3x. That's going to be negative 7x. So let's fix that here. 3x. Yeah, 3. There we go. 3 and 1, right? Yeah, 3 and 1. There we go. So that's 3x minus 2x. So that checks out. And we can finally do one last thing here. When we have this negative 3 power, x to the negative 3 power, x to the negative 3 power, I'm putting over here on the side, is the same as 1 over x to the third power. So we can rewrite this whole expression, if we want to, as 2 times 2x minus 3, it's quantity x minus 1, over x cubed. Okay, so I hope the idea is to get you in the frame of mind to be able to see things like this. We're going to come back to these later in the year. Okay, let's see here. All right, here we have x plus 5 plus 6x to the negative 1 power. Well, what we have here is we have x to the 1 power, and we have plus 5x to the 0 power. When you have just a number by itself, that's x to the 0 power plus 6x to the negative 1 power. And so our greatest common factor in this is going to be our lowest power of x, which is going to be negative 1. So we have x to the negative 1 power, and x to the negative 1 power times what equals x to the first power? Well, that's going to be x squared, because x to the negative 1 power times x squared, we add our exponents together, we get x. And then x to the negative 1 power times what equals 5x to the 0 power, well, that's going to be plus 5 x, because x to the first power times x to the negative 1 power is x to the 0 power. And finally we'll have plus 6, and then that's going to be equal to x to the negative 1 power times quantity x plus 2, x minus 2, or x minus 3, excuse me, x minus 2. It's going to be plus. There we go. And we can go ahead and take this x to the negative 1 power and make this our denominator. So we have quantity x plus 2, that's quantity x plus 3. Okay, next. So now this one here is kind of strange. Well, our number for our greatest common factor, you take the lower of the numbers, so we're going to have our greatest common factor is going to be equal to 1/2, and then the power of x that is the lowest, well, that's going to be x to the negative 3/2 power. So that's going to be our greatest common factor. So let's write this out here. We're going to have 1/2 x to the negative 3/2 power, and 1/2 times what equals 1/2? Well, times 1. And so what times x to the negative 3/2 power equals 1/2? Well, that's going to be x squared. Now, I hope you can see that, because negative 3/2 plus 4/2 equals 1/2. And so negative 3/2 plus 2 equals 1/2. And so therefore x to the negative 3/2 times x squared is equal to x to the 1/2 power. And then what do we have here? Well, what times 1/2 equals 2? Well, that's going to be 4. And then what times x to the negative 3/2 power equals x to the negative 3/2 power? Nothing. So we have here is 1/2 x to the negative 3/2 power, and using a difference of squares, we're going to have x plus 2 times x minus 2, and then we have this negative 3/2. Well, x to the negative 3/2 power is equal to 1 over x to the 3/2 power. And then we can use write this as a radical expression. We're going to have 1 over square root of x cubed. So therefore, we're going to have, our answer is going to be, we have 1/2. So since we have 1/2, this 2 and the 1/2 goes in the denominator. And we're going to have this x to the negative 3/2 power is going to be down here, square root of x cubed. And in the numerator, we have quantity x plus 2 times quantity x minus 2. And also, I haven't brought this up yet in this session, but in this expression, x cannot be equal to 0 because we can't divide by 0. Okay, next we have this this expression, and we have x squared plus 1 in both cases, but the lowest power is this to the negative 1/2 power. So our greatest common factor is going to be this quantity x squared plus 1 to the negative 1/2 power, and that's going to be times this x squared plus 1, because x squared plus 1 to the 1 power times the same thing as a negative 1/2 power is going to be to the 1/2 power, so that takes care of that, plus 3, because we have this expression here. So we're going to end up with x squared plus 1 to the negative 1/2 power times, we're going to have x squared plus 4. And this x squared plus 4 is not factorable, but this value here, this to the negative 1/2 power, is going to be, by taking the square root and moving it down to the denominator, so we're going to have in the numerator x squared plus 4. In the denominator, we're going to have square root of x squared plus 1. So that's going to be as simplified as we can make this. And I think this is good for all real numbers. Anyway, let's go on to F. Okay, well, let's look at this. What do we have here? Our greatest common factor is going to be our lowest power of x. So that's going to be just x to the 1/2 power. So we have x to the 1/2 power x to the 1/2 power times what equals x to the 3/2 power? Well, it's going to be x, because 1/2 plus 1 equals 3/2. And then if we take this out of here, we're going to have plus 3/2, and we're going to have this x plus 3 left over, or x minus 3. And then we can just we could simplify what's inside of here. X plus 3/2 x equals 5/2 x. And then we're going to have this 3 times -3. So 3/2 times -3 is going to be -9/2. So we're going to have x to the 1/2 times 25/2 x minus 9/2. And then we can take this x to the 1/2 power and just simplify that to be square root of x. And so this would be our simplest form. Okay, next we have this one here. We have expressions of 4 plus 5x and 8 minus x in both terms. And so you're looking for the greatest common factor is going to be the lowest power. Well, we have 4 plus 5x squared and then just 4 plus 5x. So our greatest common factor is between these two is just going to be 4 plus 5x. And then we look for this 8 minus x. Well, we have to the 5th power here and to the 6th power here, so our lowest one is 5th power. So we have 8 minus x to the 5th power. And so we're going to multiply this by, okay, what do we multiply this by to get this here? Well, we're going to have, we want to get 4 plus 5x squared. We have 4 plus 5x. We're just simply going to have 4 plus 5x. And then what do we multiply this by to get this over here? Well, already we have 4 plus 5x, so that doesn't count. And so we're just going to have, we want to multiply this 8 minus x to the 5th power by something to get 8 minus x to the 6th power. Well, that's going to be 8 minus x. And so we just simplify inside here. I'm just going to rewrite here. 4 plus 5x times quantity 8 minus x to the 5th power. And then we have, we just combine the terms together. We're going to have 5x minus x, so that's going to be 4x. And then we have 4 plus 8, which is going to be plus 12. And we can further factor here because between 4, our greatest common factor here between 4 and 4x and 12 is going to be 4. So we can write this out. We can bring this 4 out in front. So we can put 4. And I'll just rewrite the order here. We'll have x plus 3. And then we have times quantity 4 plus 5x times quantity 8 minus x to the 5th power. And we can even do different things than that too, but we're just going to leave it here. Okay, h. Now here we're given a combination of rational and radical in the terms. Well, this 1 minus x squared, square root of 1 minus x squared is 1 minus x squared to the 1/2 power. So I'm going to rewrite this expression in rational form. So we have 1 minus x squared to the 3/2 minus 3x squared, and this square root of 1 minus x squared is 1 minus x squared to the 1/2 power. And so now we have something we can work with. What's going to be our greatest common factor? Well, you look for the lowest power of this thing here, which is to the 1/2 power. So we're going to make this quantity 1 minus x squared to the 1/2 power. And then we're going to have times, so 1 minus x squared to the 1/2 power times what equals 1 minus x squared to the 3/2 power? Well, it's going to be simply 1 minus x squared, because this is to the 1 power, this is to the 1/2 power, add 1 and 1/2, you get 3/2. And then we're going to have here minus 3x squared, and then yes, to the 1/2 already. So now we can write this as 1 minus x squared to the 1/2 power times, we're going to combine these terms here. We're going to have 1 minus 4x squared, and we can factor out a negative sign here, and we can rewrite this as, bring this negative sign out front, and you'll see why I'm going to do this here. We have 1 minus x squared to the 1/2 power, and then we're going to have negative times 4x squared is negative 4x squared is going to be 4x squared, and then we're going to have negative times 1 is negative. We can use a difference of squares now, so we have negative, and what I'm going to do is take this 1 minus x squared to the 1/2 power and rewrite this in radical form. So we have 1 square root of 1 square root of 1 minus x squared, and then we're going to have this difference of squares here. So what is the square root of 4x squared? Well, it's going to be 2x, and then we're going to have plus and minus 1. So yeah, a lot of little things here, but we'll be doing certain things like that this year. Most of them will not be this complex, of course, but just to be ready as possible. Okay, the last one in this set we're going to look at is this one. I'm going to rewrite, we have radical form here, so we have 6x times quantity 1 minus 2x to the 4/3 power, and we're going to have minus 8x squared, and then this cube root is going to be 1 minus 2x to the 1/3 power. And so now we're going to be able to look at our greatest common factor here. Well, between 6 and 8, I think 2 would be the thing we had to work with. So 2, and between x and x squared, we're going to have x. And now 1 minus 2x to the 4/3 power and 1 minus 2x to the 1/3 power, we're going to have 1 minus 2x to the 1/3 power. Okay, and so what do we multiply this by? Well, what do you multiply by 2 to get 6? 3. What do you multiply x by to get x? 1. So we just leave that there. What do you multiply 1 minus 2x to the 1/3 power by to get 1 minus 2x to the 4/3 power? These are 1 apart. So we're just going to multiply this by 1 minus 2x. And so that takes care of this thing here. And next, what do you multiply by 4 to get negative 8? Well, that's going to be negative 4. And then what do you multiply by x to get x squared? X. And then what do you multiply 1 minus 2x to the 1/3 power to equal 1 minus 2x to the 1/3 power? Just 1. So there we have this. And so simplifying out here, we're going to have 2x times quantity 1 minus 2x to the 1/3 power. And then we're going to have 3 times 1, and 3 times negative 2x is going to be negative 6x, and we're going to have minus 4x. And so now we're just about ready to finish this up. So we're going to have left over 2x, and this 1 minus 2x to the 1/3 power is going to be the cube root of 1 minus 2x. And then we're going to have left over this negative 10x plus 3. And so how did I get negative 10x? Was that right? Negative, something might be wrong here. Negative 4x, that's right. Yeah, I think that's right. I might have made a minor mistake on this. Anyway, this is just a review and preview of what's to come. Should be helpful for this year. Good luck, and as always, thanks for viewing.